Have you ever looked at a perfectly vibrant 100% natural fruit? Something packed to the absolute brim with vitamins, antioxidants, and age-old healing properties, and wondered if it could possibly harbor a hidden DNA-damaging secret? I mean, we tend to assume that if something is pulled straight from the earth and slapped with the label superfood, it's completely, unequivocally harmless, right? Well, science has a really funny way of challenging our most basic assumptions. And today we're going to explore exactly that kind of paradox.
So let's jump right in. Welcome to our latest explainer, where we're unpacking a truly fascinating recent scientific study. As you'll see, this research uncovers the surprising dual nature of an underutilized Andean crop known as the tree tomato. We'll be looking at its rich phytochemical profile, its stellar nutritional benefits, and, most importantly, the totally unexpected genotoxic activity found in specific parts of its orange and purple varieties. Get ready, because this might just shift how you look at natural foods. Okay, to really get what's going on here, let's get familiar with the plant itself. This is Silenium betachaceum, better known as the tree tomato, or tamarillo. It's this fast-growing, small tree that's native to the Andean region of South America. The researchers behind this specific study actually focused their sampling on fruits collected from the Cultivo rural parish, right in the Tungurahua province of Ecuador. It's a gorgeous, vibrant fruit, and you'll often spot it in local markets showing off these deep orange and really rich purple hues.
And honestly, it's not just pretty to look at. This fruit has been an absolute staple in Andean culture for generations. The traditional uses are just incredibly widespread. Locally, people consume it heavily in juices, jams, and compotes. It's used as a natural food coloring for sweets and even pops up in savory stuff like condiments, chutneys, and roast lamb stuffing. But looking beyond the kitchen, indigenous cultures have used almost every single part of the plant, from the fruit itself all the way to the leaves and the peel for ethnomedical purposes. We're talking treatments for everything from throat aches and tonsillitis all the way to anemia.
All of that rich traditional history translates seamlessly into its modern reputation. Basically, it's a nutritional powerhouse. It's low in calories and sodium, but it is incredibly rich in dietary fiber, essential vitamins like A, B6, C, and E, plus crucial minerals like potassium and iron. Because of this stellar profile, it's actually gaining some serious global attention. Nutritionists and researchers are highly interested in how it might help manage cardiovascular health and mitigate conditions tied to oxidative stress. I mean, on paper, it sounds like the perfect functional food, right? The underlying chemistry brilliantly illustrates why it is so beneficial for us. When you zoom in on a molecular level, you start seeing these highly complex chemical structures, bioactive phytochemicals like rosmarinic acid, lutein, and delphinidin. These terpenoids, flavonoids, and phenolic acids are literally the molecular engines that give the fruit its incredible antioxidant, anti-inflammatory, and even antimicrobial properties. You're basically looking at the chemistry of a superfood at work. But here is the plot twist. Despite being heavily consumed and widely celebrated as a functional food, the tree tomato is actually a highly understudied crop when you look at comprehensive safety evaluations. We know it has this amazing nutritional value, but there is a massive research gap regarding its genetic variability and, crucially, any potential genotoxic effects. Now, genotoxic simply means something that has the ability to damage the genetic information inside a cell, which can cause mutations. The researchers realized that before we start concentrating this fruit into pills and nutraceuticals, we really need to make sure every single part of it is actually safe at a cellular level. So, to fill this gap, scientists decided to put two prominent Ecuadorian varieties to the ultimate test, the elliptical orange variety and the purple variety. But they didn't just toss the whole fruit into a blender. No, they meticulously separated both varieties into their individual plant organs, the pulp, the peel, and the seeds. Then they created polar extracts from these distinct parts using different solvents like ethanol and water. Essentially, they pulled the chemical compounds out so they could test them individually. To test these extracts, the researchers used a totally fascinating method called the alkaline comet assay. Think of this like cellular forensics. They took Chinese hamster ovary cells, which are a standard model for normal healthy cells, and exposed them to the various tree tomato extracts. Then they apply an electrical field. If the DNA inside the cell is healthy and intact, it stays put in a nice tight circle. But if the extract caused DNA damage, those broken genetic fragments get pulled away by the electrical charge, creating a shape that looks exactly like a shooting comet with a tail. The longer and brighter that tail is, the more severe the DNA damage. Now, at first glance, everything looked totally reassuring.
When the cells were exposed to the extracts at various concentrations, cell viability stayed well over 85% across the board. The extracts weren't outright killing the cells. In fact, statistically speaking, there was no significant difference in cell death between the extracts and the safe negative control group. So far, so good, right? But then, the researchers ran the COMET assay at a higher concentration of 100 micrograms per milliliter, and boom, we get our first major shocker from the data. While most of the purple variety's extracts were perfectly fine, the hydroethanolic extract of its seeds actually induced significant DNA damage. The comet tails were prominent. The very seeds of this nutritional fruit were actively damaging the DNA of those healthy cells. And if you thought the purple variety was wild, let's look at the orange variety because the plot definitely thickens here. For the orange tree tomato, the seeds were perfectly fine, but the peel was an entirely different story. The ethanolic extract of the orange variety's peel acted as a significant genotoxic agent. Once again, they found very clear evidence of DNA fragmentation. So if we lay this all out, the crucial point reveals some highly specific danger zones. The pulp, which is, the part most of us actually eat, is perfectly safe in both the orange and purple varieties. However, the toxicity is entirely dependent on the variety and the specific plant organ. We're talking danger for the purple seed and danger for the orange peel. Now, you might be asking yourself, how is this even possible? How can a fruit packed with healing antioxidants suddenly damage DNA? Well, the researchers investigated the molecular mystery behind these chemical culprits. And it turns out, under specific conditions, especially during certain extraction methods, those beneficial polyphenols can actually flip and act as pro-oxidants. They can generate reactive oxygen species, or ROS, which are essentially these unstable molecules that just attack DNA. On top of that, infrared spectroscopy hinted at the presence of polycyclic structures in the problem extracts. Those are super common in naturally occurring but potentially mutagenic compounds. And this leads to a super practical, real-world takeaway straight from the scientists. They explicitly advise caution when you're using the peel of the orange variety or the seeds of the purple variety in procedures involving alcohol. Why? Well, because those dangerous compounds were extracted using ethanol and water. That means artisanal tinctures, craft alcoholic beverages, and fancy mixology cocktails that muddle whole, unpeeled tree tomatoes could inadvertently be extracting and concentrating these exact DNA-damaging agents right into your drink. So the tree tomato really does possess a true dual nature. It is undeniably a fantastic source of beneficial bioactives, vitamins, and minerals. The pulp is a wonderful food, for sure. But specific parts of specific varieties also act as potential genotoxic agents. This strongly reinforces why we absolutely need detailed cultivar-specific safety and dosage assessments. As the wellness industry rushes to turn every natural fruit into a concentrated supplement, pill, or powder, studies like this are a great reminder that concentration can sometimes magnify risks we literally never knew existed. Which really leaves us with this final, provocative thought. Does 100% natural always mean harmless? We've seen today that the line between a healing superfood and cellular toxicity can be as thin as the peel on a piece of fruit, or dependent entirely on the color of the variety you happen to choose. Nature is just incredibly complex, operating on this delicate chemical balance. So the next time you see a new exotic superfood supplement promising you the world, you might just find yourself wondering, hey, which part of the plant did they actually use to make this?